Question number 21 on the 2025 AMC 8. This question is interesting because it's based on graph theory. And this is a little hard for 8th graders or below. But let's see what can we do. Okay, so what we can do to analyze the question. First of all, let's see what the question is asking. Right, so the Königsberg school has grade 1 through 7 and assign them to the pods A, B, C, D, E, F, G. 1 grade per pod. Okay, some are connected with walkways and some are not. And we just don't want consecutive numbers, the grade numbers, to be connected with the pathways. Right, so we have the grade 1, 2, 3, 4, 5, 6, 7. And we have the pods A, B, C, D, E, F, G. And we have a graph here to see which one is connected to what. So at first glance, this is pretty hard to do. Maybe we just try assign some numbers randomly and see what happens, see if it works or not. But that's going to be a lot of choices, so it's really hard to do just randomly. Yeah, because if you know about counting, some basic about counting, the random assignment is they're like 7 factorial. Okay, so 5,040. That many choices. We can't try one by one, right? But then let's take a look at the graph carefully and see some patterns here. Right? And then questions asking for the grade level C, E, and F. Okay, so those pods, C, E, and F, what kind of grade levels assigned to those? And then we want to add them up. Okay, so we don't need to care about the final assignment at A, B, D, and G. But that makes it a little bit simpler. Okay, so first of all, let's take a look at some of the pods, A, B, C, and F. Those four, from the pathways connecting to them, it looks like they are all connected to each other, because any two of them are connected. So in that means what? That means the numbers we assign to them should not be consecutive at all. Okay, so between any two of them, they cannot be consecutive. But 1, 2, 3, 4, 5, 6, 7, the only way you pick four of them to be non-consecutive is 1, 3, 5, 7. So, okay, so those four have to be the A, B, C, and F. I don't know which is which yet, right? So, but we know that these four has to be 1, 3, 5, 7. Then that means the remaining three, D, E, and G have to be what? 2, 4, and 6. 2, 4, and 6. Right, so those are the two groups of the numbers. Okay, so then let's take a look at the connection between the two groups. Right, so you see that the pod D and E are connected with C, and the pod E and the G are connected with F. So that means what? That means this point C, the number in C, cannot be next to D and E. Okay, cannot be next to D, cannot be next to E. So, okay, so among those numbers, 1, 3, 5, 7, let's see which one can work, right? So let's say C is a 3. If that's a 3, the two numbers are next to 3 is what? It's a 2 and a 4. So we have 2 and a 4. We have 2 and a 4 among D, E, and G. Now we don't want 3 to be next to 2 and a 4. So D and E cannot be 2 and 4. But there's only one number left, 6. You cannot put the same number into two pots, right? So that means this is not possible. You cannot put 3 here. Same thing to 5, right? So if you put 5 there, it's gonna mean what? 4 and 6 cannot be next to each other, cannot be in D and E. But we have to put one of those in D and E, right? So we cannot just put 2 in both of them. So that means 5 cannot be here either. So it just have what? 1 or 7 left over. 1 or 7. And if you think about the F, that's the same thing, right? That's the same thing. You cannot put 3 and 5 there because F is next to E and G. You cannot put 3 or 5 there because each of them will have the either of those two numbers that's consecutive with them. So we cannot place them. So okay, so F can only be 1 and 7 also. So that means what? C and F will be 1 and 7. I don't know which is which, but these two will be 1 and 7. Right? So A and B have to be the 3 and 5. Right? Again, I don't care which and which, or maybe we are not to that point yet. Okay, so we at the end we are answering C, E, and F. So we don't really worry too much about A and B. Now let's see, there is a E left. Okay, we know C and F, 1 and 7, maybe this one 7 or maybe 7 and 1, but the sum is the same. So let's not worry about which one is which yet. Let's look at E. Let's look at E. And E is next to both C and F. Okay, so E, that means what? E has 3 choices, 2, 4, and 6. 2, 4, and 6. Think about 2. What if it's 2? It's next to C, next to F. If 2 is put it in E, then that means it has to be next to 1, which is not allowed. Okay, we don't want consecutive numbers to be next to each other, to be connected with the pathways. So that means you cannot put 2 there. Same thing with 7. The same thing with 6, right? So if the 6 is put in E, then it has to be next to, then it's going to be next to 7 because the pathways, right? So pathways to C and F. One of C and F is going to be 7. So you cannot put 6 there either. That means there's only one way you can put 4 for E. Okay, at this point, we can answer the question already. Okay, so 1 and 7 will be C and F. I don't know which and which, but it doesn't matter because the sum is the same. Then E has to be 4. So we have 1, 4, 7 for these 3 points. Then the sum will be 1 plus 4 plus 7 is 12. And the answer should be 12. At this point, we can actually give the answer, but to be complete, we have to make sure that everything works, right? So there is a way to make it work. So, well, that's actually not so bad, okay? Not so bad. If we have a 4 here for E, and then this, we can put 1 for C and a 7 for F, right? And then the D has to be a 6, and the G has to be a 2. And 3 and 5, we don't want A to be 3, so A is 5 and 3 is in the middle. Then that way, this whole thing works. So this is one way that make it work. So then that means our choice actually is a good solution. Okay, so that's a very interesting question, and then we'll going to talk about the next question.